So in the last video, we started the lab programming. So in that, up to the sixth program you've done. So 6 is nothing but multiplication, division, square, cube. So those programs were completed in the previous class. So today's next program we are going to study about program to add two 16-bit numbers. So just try to read the title. Program to add, that means addition bit for the two 16-bit numbers. Two 16-bit numbers is nothing but, for example, in previous you've done 8-bit numbers, addition for 8-bit numbers. 8-bit number is nothing but only the 2-bit numbers. So for example, if I write 11 plus 11, so that means this is 1 bit, this is second bit. That means I can say this is 8-bit, this is also 8-bit. So just to remember in your mind, where if they say 8-bit is nothing but 2-digit numbers, one number and second number, only two numbers are there. This is the 2-digit number is nothing but this is the 8-bit number. So if they ask the 16-bit number, means 4-digit number you have to take. 4-digit is nothing but instead of 11 here, if I consider something like here 1 2 3 4, again 1 2 3 4. So in this what will happen? So this is 2-digit number. If you consider only 3 4 and 34, if you consider these two, this is 8-bit level. This means only 2-bit numbers. So if you consider 4-digit numbers, so that is nothing but this 16-bit number. So that means if you want to represent in binary, it will take the 4-digit representation. Again this is 4-digit, 8-bit. So again 4-digit means 12. Again 4-digit means 16-bit number. So that means if they say 16-bit number, means you need to think about in your mind you need to remember the number should be 4-digit. If they say 8-bit number, means in your mind it should be 2-digit numbers. So in the previous last class we done only for the 2-digit numbers for addition. For this program it is the 4-digit numbers. Is it clear? In 4-digit numbers what will happen? Instead of going for direct program here, just go for the calculation part here. So here I will take the one example. So 16-bit with 4-digit number, one number, and second number is also 4-digit number. So here I will take 5AE1 plus addition of 9C 9D. So here just use the calc here, no problem. Just use the calc and type this hexadecimal number and perform this addition in the hexa. You will get the F77E. Is it clear? So in just I will explain this in the binary level. What is the importance here? So here just I will convert this hexa number to binary. So that means 5 is there. Binary equivalent of 5 is 0101. A, that equivalent is binary 1010. E, that is the 1110. 1 means 0001. Similarly for the binary equivalent of second number, I written complete here. Is it clear? So already you know the addition here, binary addition. So here, so already you know that binary addition. So in a binary addition combinations already you know. So just I will repeat one more time. So if the addition between the 0 0, your output is 0. If the combination is 0 1, your output will be 1. If the combination 1 0, your output is 1. So last one, if the combination is 1 1, it becomes 1 1 means 1 carry, sum is 0. Is it clear? If one more is that if they given the 3 here, here what will happen? For the addition of 1 1, so here 1 1 means it is 1 0. That means 1 1 becomes this is 1 0. So next one more 1 is that if you add here 1 means 1 1. So that means I can write 1 carry 1 sum. So that means in binary addition for 0 0 obviously sum is 0. For 0 1 or 1 0 combination your sum will be 1. For the two ones, 1 1 means 1 carry 1 sum 0. Similarly for the 111 means 1 carry 1 sum is there. So this one you need to remember because this one you last semester you studied, but you try to remember. So here also what will happen? Binary addition 1 1 1 0. Again 0 1 means 1. 0 1 means 1. 0 1 means 1. Similarly 0 1 means 1. 1 0 1 1 0 1. So 1 1 means 1 0. 0 0 0. 0 1 means 1. 1 0 1. This is 0 1 means 1. Last 1 1 means 1 0. So triple ones are there. Already I said 1 1 means 1 0. Next plus 1 means that is 1 1. So just I explained here. 111 means 1 carry 1 sum. Same thing, 1 carry 1 sum. So here again 1. So last again 1. This is 0 1 means 1. So what is the representation here? This is 4 ones means F. So this is 0 triple 1 means this is 7. 0 triple 1 means 7. Triple 1 0 means this is E. Is it clear? So here you need to understand very important thing. So this is the see here. This is 4 digit 4 bit 16 bit. Is it clear? If you make it divide here, so middle if you make it divide like this, is it clear? So that means this 4 plus 4 8 bit. That means this is the 1 byte. So that means I can say this is your 1 byte. This is your second byte. Is it clear? So that means like that n number of bytes are there. For example, is it clear? At the time what will happen if you want to perform for the addition of this first byte. Is it clear? If you want to perform the addition of this first byte, at that time you are going to use the add instruction. If you write simply add instruction and content between these two, so that means you are using the some other registers also here, one accumulator and one more other registers also. Okay, add, by using add instruction you can perform these one. Is it clear? But in the second stage what will happen? So already I said this byte is the lower byte. Is it clear? Byte means 8 bit numbers. So this is the lower byte. So this one is your the higher byte. So at the time one carry, this is your carry. Carry is coming from lower byte to the higher byte. So see, this is very important. So this one carry is coming from this lower byte. Already I said this completely lower byte, this higher byte. One carry is coming from lower byte to the higher byte. Is it clear? So at the time what will happen? Here also I need to perform the addition. Is it clear? But I need to consider one carry is coming from lower byte to the higher byte. Is it clear? At the time if you write same instruction add here, it is not going to consider this carry. Because of this is carry is propagating from the this byte to the higher, lower byte to the higher byte. At the time if you want to consider this carry, is it clear? At the time I need to use the one more instruction. This is the add C. This is addition with carry. This is just addition. Is it clear? So for other example, if same like this carry, one more carry is coming from the any of the previous stage here, previous any number, at the time you can use the add C carry also. Is it clear? So that means finally what will happen? Already final I got this result. This result also it is a 16 bit data. So already you know in the addition any arithmetical operation, result will be in the accumulator only. But accumulator is only the 8 bit register. 8 bit register is nothing but it capable to store only the 2 digit number. But here the 4 digit number is there. It's not possible. That's why I will break this one in such a way that here whatever the lower byte is there, this result I will store the one of the register R4, and whatever the higher byte result is there F7, I will store in the one more register, that is the R5. You can see the content of this register itself, you are the result of this example. Is it clear? So once you understood this one, your program becomes very easier. And one more important thing is, so here this is a one number, complete this is a one number, this is your second number. But I can't load this entire 16 bit number into your accumulator or some other register, because those are only the 8 bit registers. So how can I load this one? So I will load in such a way that this entire 8 bit data, or I can say this is entire the otherwise you can take this one, entire 8 bit data or entire this 1 byte, I will store this is one in the R0 register. So next byte, this is 8 bit or the next 2 bit number. 2 bit I stored in R0. Next 2 bit number I will store this is one in the R1 register. So similarly, so next this number I will store in some other register R2. So similarly, so last one I will store this one register in the R3. So that means instead of taking 16, I can't take 16 also. For that I will take this is number, 2 digit number. This one I will store in R0. This number I will store in R1. This number I will store in R2. This one I will take, this is in the R3. Your result will be in the R4. So this will be in R4. This will be in your R5. Is it clear? So that means once you understood this mathematical, how to do the calculation, how to store, if you understood, your program becomes very, very, very easy. So just I will explain the program how to write. So here I written just for your understanding purpose. So here I will take input register R0, R1 and R2, R3. Is it clear? Here I took the two numbers. Result is F77E. Is it clear? So to store the output, I will take two registers, that is the R4 and R5. Is it clear? So how to write the program? See here. First one, this is same ORG 400H. This is always same. First line, and last one is the end. Is it clear? In between, I need to write my program. So how to write here? Move R0 comma hash 0 E1H. So that means I am taking the first number. Is it clear? So I am taking this first number. I am loading this first two digit number E1. I am loading to the R0. Similarly, move R1 comma hash 5H. So next number 5A. I am loading to the register R1. Similarly, move R2 comma hash 9DH. So that means this number I am taking 9D. So you have to take from the something like lower byte to the higher byte. First you have to take lower byte, then next higher byte. Here also first, then you have to take lower, next higher byte. Don't take first number this as the lower. You don't consider first number and second number. Otherwise your calculation entire become wrong. First you have to take lower byte, next higher byte. Second number again lower byte, next higher byte. So first I completed the first number by using these two. So second one, what will happen? Again I need to take the lower byte, that is 9D. So move R2 comma hash 9D. So 9DH. So similarly move R3 comma hash 9CH. So 9CH. Is it clear? So that means by using 4 lines. So that means by using these 2 lines I loaded the number 5A E1. So by using these 2 lines I loaded my number 9C 9D. Is it clear? So here I am writing the H, that is nothing but these numbers are hexadecimal numbers. Always you need to represent with the hexa, that is the H. Is it clear? So after the loading of these numbers, I need to perform the addition. Is it clear? So how to perform the addition here? So that means first these are the two numbers. Is it clear? First I need to perform the addition for E1 and 9DH. E1 and 9D, or you can see this one, no problem. So E1 binary equivalent this one, 9D binary equivalent this one. That means I need to perform the addition for these two numbers. So which number? E1 plus 9D. Is it clear? So where is the E1 and 9D here? E1 it is in the R0, 9D it is in the R2. That means I need to perform addition for R0 and R2. Is it clear? So how to write equation? Just I will load R0 to the one accumulator. Is it clear? So how to load? Move A comma R0. So that means this 0E1 are loaded to accumulator A. So next line, add A comma R2. So that means addition between the content of accumulator with R2. That means R0 itself, that is accumulator. That means E1 plus R2 means plus 9D. Is it clear? And don't try to add comma R0 comma R2. This is a wrong that's a wrong instruction, because we can't use both the registers at the instruction. Is it clear? So one should be accumulator. That's why I will load first accumulator, then I will take the second number. After the addition here, is it clear? So what will get the result here? For addition of these two numbers, I will get the 7E. Is it clear? So that means this accumulator, that means here your 7E, that result obviously it will be in the accumulator only. Is it clear? So the next one, this result I will store in the R4. So by using move R4 comma A. So that means this 7E I am storing in the R4. Is it clear? So what is the next one here? So I done E1 plus 9D. Next I need to go for the 5A plus 9C. So where is the 5A here? 5A is in the R1. 9C is in the R3. I need to perform the R1 plus R3. Is it clear? So I can't write the equation as both the registers. That's why I will load R1 into the accumulator. Then I will perform the addition. So how to write? Move A comma R1. So that means 5A, that value I am loading to the accumulator A. Is it clear? So next I am taking add carry. This is very, very important. Add A double D C. A comma R3. Previous I took only A double D. Here I am taking A double D C, addition with carry. The difference between these two, already I said, here I am performing the addition, but there is no carry from the previous any of the byte number. There is no number at all here. That means obviously there is no carry. At the time I will take simply the addition. But in second case, what will happen when you performing these two numbers, 5a plus 9c. So this is the lower byte, this is your higher byte. So one carry is coming from your the lower byte to the higher byte. That means this carry. This carry is coming from this completely lower byte to the higher byte. At that time, I need to consider this carry along with these two numbers. I need to consider. At that time, we are going to use the add C. Clear? So how to write? Add C a comma R3. Is it clear? After writing this one, it is going to consider 5a plus 9c plus 1 carry from this lower byte. So 3 numbers it will consider by using the addition C carry. Is it clear? So by using this instruction, you will get the result. This is the F7. So what will happen? So here you will get F7. So F7 is going to store in the accumulator. Is it clear? So this line. F7 is going to store in accumulator. Similarly, this F7, whatever the content, I am moving to the R5. Is it clear? So last one is the end. So that means what you got the result here? F7 7E. So that means if you want to see the result in your software, you need to see itself the content of R4 and content of R5 itself, you are the result of this addition. Is it clear? And somebody they can ask here, sir, why are you using the R4 and R5 register? Directly we can see the content accumulator itself. But problem is that first I perform this byte level addition here. This result it going to store in accumulator. Is it clear? Next time also when you performing the here addition, this result also it going to store in accumulator. But what will happen? But this one I need to retain the value. But because what will happen here, if you want to load this in accumulator, this data it will get lost. That means this data it will get lost and it will update by only the F7. That's why in order to lose the data here, intermediate result I will go to store in the some other registers R5 and R4. Is it clear? And make it practice this one. And don't make it by heart. As much as possible, take paper and pen and make it practice to write it. Is it clear?